Even when we were children, the stars intrigued us, excited us, inspired us. We looked into the night sky and we wondered, what's beyond what we see up there? Hi, I'm Marcus Lloyd, and in this series, we will answer some of the questions you may have asked yourself. We'll take a journey together, a journey through the universe. We'll look at ways God's creation is confirmed by science, and we'll see that the heavens described in the Bible are consistent with all we've learned about space. Today we know that there are more stars than grains of sand on this beach, many more. But what else do we know? The stars have a lot to teach us, and they've been sharing their lessons for thousands of years. As humans began to understand the passage of stars across the night sky, they found a connection in the migration of birds and other animals, the food they hunted to survive. They learned when to plant and harvest crops by tracking the movement of the heavens. In time, they even found ways to navigate ships by them. The ancients used the motion of the stars to guide their activities, but they couldn't explain why the stars moved as they did. That part remains a mystery. What could explain it all? The answer has been right here for millennia in our one infallible guide, the Bible. Our universe is so complex, so intricately designed that it seems obvious that a supernatural power would be required to create it. Since the earliest of days, we've looked to the stars to help us find our way. As it says in Genesis, "Then God said, 'Let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons and for days and years.'" God designed those celestial lights for us, and they can guide us through space and time. All we have to do is watch their movement across the sky. Come on, we have a grand journey awaiting us. So, let's get started. First, let's get our bearings. It's not hard to do these days. Download an app, point your smartphone at the night sky, and it'll identify stars that are millions of miles away. But for thousands of years, the heavens were a great unknown. But people did notice patterns. When they looked to the sky, everything seemed to move from east to west. It's called diurnal motion.
We see that during the day. The sun rises in the east and it sets in the west, and that's because the Earth is rotating in the opposite direction. Now, this is an important phenomenon because it helps us tell time. We know that the sun is in the east in the morning. It reaches its highest position around noon, and it sets in the west in the evening. And then a similar thing can be used to figure out the time of night with the positions of the constellations for a given time of year.
What we see up there helps us navigate the world down here. As we make our orbit around the sun once a year, the tilt of Earth on its axis causes a change of seasons. So when it's winter in the northern hemisphere, it's summer in the southern hemisphere. The moon, which orbits us as we orbit the sun, also affects our planet. Its gravitational pull causes the daily rise and fall of the tides. Each month, we watch the moon pass through its lunar cycle. 12 of these mark a year. But how do we mark passages of time longer than a year? The answer is there in God's design.
The rotation of the Earth is basically like the second hand on a clock. It measures the fastest movement of time in the night sky, tells us the time of day. Now, the orbit of the moon around the Earth, that tells us the time of month. And then the hour hand would be like the Earth orbiting the sun. Now, for units of time longer than a year, we need more hands on the clock, and that's what planets are. But if you could look at the solar system from above, it would all be very straightforward. The planets would orbit the sun in what appears to be circles in a counterclockwise direction.
The moon is a calendar system, and it helps us to keep track of history. There are certain episodes in the Old Testament, such as the book of Amos, where an eclipse is mentioned. And we do have eclipse data. They are so predictable. This helps us to date some of the details of the Old and the New Testament. And thinking about the moon and the calendar, the date for Easter each year is actually determined by the moon. There's a complicated formula that goes along with that. It involves a full moon and the first Sunday after the vernal equinox. But how interesting that the date for Easter, this Christian holy day, is set by the created moon.
For thousands of years, astronomers had only their eyes to observe the heavens. There were no telescopes, no spacecraft. They studied how the stars moved through the sky and were able to predict approximately how these objects would appear in the future, but they had no idea why the stars moved. Back in the old days, most people had no idea that the Earth rotated and orbited the sun. You can't feel it happening, so it was natural to assume that the objects in the sky were revolving around the Earth. Ancient astronomers were trying to predict the future positions of planets without understanding the underlying mechanism. We were still early in our journey of discovery. In the 2nd century AD, Claudius Ptolemy, a Greek mathematician and astronomer in Alexandria, invented a model of the solar system.
Ptolemy's model of the solar system was the most accurate that had been developed at the time. He was able to predict the positions of planets and the sun and the moon with unprecedented accuracy, despite the fact that his model was really wrong in terms of its understanding of the nature of the solar system. Ptolemy's model was geocentric, meaning it had the Earth at the stationary center of the solar system with all the planets and the sun and the moon orbiting the Earth.
Ptolemy's model also failed to naturally explain a phenomenon we call retrograde motion.
Retrograde motion is the apparent backwards motion of a planet that occurs when the Earth passes that planet in its orbit. It's a bit like when racers are running on a track and the guy on the inside track passes the guy on the outside track. Well, the guy on the outside track seems to be moving backwards, even though he's really moving forward. It's the same way with the outer planets. They seem to go backwards as the Earth passes them in their annual orbit.
Even though it wasn't right, Ptolemy's model made accurate predictions. It would be used for over 1,000 years. Further progress in astronomy would have to wait for a cultural revolution in scientific thinking, the Christian worldview. The brilliant mathematician Freeman Dyson once said, "It is probably not an accident that modern science grew explosively in Christian Europe and left the rest of the world behind." 1,000 years of theological disputes nurtured the habit of analytical thinking that could also be applied to the analysis of natural phenomena. The idea that the human mind can explore and understand God's creation inspired many great thinkers. Science, after years of slow progress, started to flourish, and by the 16th century, it had kicked into high gear. And that's when Nicholas Copernicus came along. "It is my loving duty to seek the truth in all things, insofar as God has granted that to human reason." He suggested a different model of the solar system, one that would have stunned early astronomers.
The Copernican model of the solar system was a leap forward in astronomy. It was superior to the Ptolemaic model, first of all, because it was closer to the truth. Copernicus's model had the sun at the center of the solar system and the planets, including Earth, orbiting the sun, rather than Ptolemy's geocentric model. Now, one advantage of this is that it naturally explains retrograde motion, the fact that outer planets seem to move backwards from our perspective on Earth. Well, that makes sense because Earth is passing them in its orbit around the sun. The Copernican model wasn't accepted by everyone right away, and part of that was there was a philosophy at the time that everything worth knowing had been discovered by the Greeks. Ptolemy was revered almost as deity, and so when the Ptolemaic solar system, which had the Earth stationary, people thought, well, that has to be it.
About 30 years after Copernicus died, a fellow named Johannes Kepler was born. And he really helped open our eyes to the true nature of the solar system. As a devout Christian, Kepler believed that God created the world according to a plan we could understand.
God himself has waited 6,000 years for his work to be seen.
Kepler grew up in a home where he had a single mother because his father had gone off to war and had not returned. He spent many years studying for the ministry and wanted to go into the ministry. He realized early on that the Bible provided a foundation, a firm foundation for science. and the creation that he saw around him had order and structure to it.
Kepler took a job teaching mathematics, and that led to a career in science.
The chief aim of all investigations of the external world should be to discover the rational order and harmony which has been imposed on it by God, and which he revealed to us in the language of mathematics.
Kepler expected to find orderly laws of nature because the mind of God controls all of nature. His Christian convictions led him to discover the 3 laws of planetary motion.
Kepler was able to figure out that planets orbit in ellipses, not perfect circles, but a sort of a squash circle, with the sun at one focus of the ellipse. That's the first law of planetary motion.
Kepler's second law says that if you take a line and you draw that line from the sun to the planet, that line is going to sweep out equal areas in a given amount of time. And because the orbit is an ellipse, that implies that when the planet is close to the sun, it will be moving faster, and then when it's farther away, it will be moving more slowly.
Kepler's third law, which he discovered later, was that the period of a planet around the sun is related to its average distance to the sun. In fact, the period squared is equal to the distance cubed when you use the correct units, and this works not only for the Earth, but all of the planets in the solar system.
And if you think about that, that is a genuinely amazing accomplishment, and these laws are still valid today. NASA still uses these laws when they're sending probes to other planets.
Kepler's discoveries 400 years ago moved us further along on our journey. He helped astronomers predict the positions of planets with unprecedented accuracy. For the first time, they began to understand the structure of the solar system. Later, scientists would refine Kepler's laws. In the meantime, a new invention was about to change the science of astronomy forever. In 1608, a Dutch eyeglass maker named Hans Lippershey patented a device that could enlarge the appearance of objects by as much as 3 times. A year later, an Italian astronomer and mathematician named Galileo Galilei heard about Lippershey's invention.
The Holy Bible and the phenomena of nature proceed alike from the divine word. God is known by nature in his works and by doctrine in his revealed word.
Galileo started his own experiments with lenses. Within days, he had built a telescope.
Most serene prince, Galileo Galilei most humbly prostrates himself before your highness.
The military uses were obvious.
This spyglass has the advantage of discovering the ships of the enemy 2 hours before they can be seen with the natural vision, and to distinguish the number and the quality of the ships.
The telescope changed everything when it was invented 400 years ago. Up to that time, people only used their eyes to look at the sky, and that's still a great way to enjoy the sky. But to do the science, you'd really want to use a telescope. And once it was invented, Galileo was the first apparently to take that newly invented telescope and look at astronomical bodies. And he saw some remarkable things.
He documented what he saw. He analyzed what he saw.
And he wrote about these discoveries in a book called The Starry Messenger, which he published almost immediately after seeing these wonderful things in the year 1610.
The moon is not robed in a smooth and polished surface, but is in fact rough and uneven, covered everywhere, just like the Earth's surface, with huge prominences, deep valleys and chasms.
He also pointed his telescope at Orion's belt and the Pleiades, these wonderful gems that are mentioned in the book of Job in the Bible. And he saw that they contained countless more stars than you can see to the naked eye. And they're very beautiful just to the naked eye. You can imagine how they look in a telescope.
I have depicted the 6 stars of Taurus, known as the Pleiades. Near them are more than 40 others.
Then he turned his telescope to Jupiter and saw something really amazing, something that no one had ever imagined.
He noticed 3 small starlets, very small but very bright, and perfectly in line with Jupiter's equator. And he thought that's kind of odd that those would be lined up that way. But what was even more strange is when he went out the next night, he saw that their arrangement was different. Their positions were different relative to Jupiter, and he couldn't figure out how that could possibly be because he was thinking that those were background stars. But then the next night and the next night and so on, he continues to watch these things, and he finds that they are circling Jupiter. These are moons of Jupiter. Now, at that point, no one had considered the possibility that other planets could have moons. There was just the moon.
I had now decided beyond all question that there existed in the heavens 3 stars wandering about Jupiter, as do Venus and Mercury about the Sun. Also, I measured the distances between them by means of the spyglass, using the method explained before. On the 13th of January, 4 stars were seen by me for the first time.
Back then, people thought there was only one moon, the one we see from Earth. No one dreamed that other planets might have their own moons. Some still believed in Ptolemy's geocentric model with the Earth at the center of the universe. But Galileo's discovery of Jupiter's 4 moons proved that not everything orbited the Earth. His later observations of Venus showed beyond all doubt that the planet was moving around the Sun, not the Earth. For many, it must have been hard to conceive. Not only were we not the center of the universe, but the Earth orbits the Sun just like all the other planets. You know, I think we take it for granted today, but back in those days, Galileo was challenging a very widely accepted scientific view. Now, some Christians embraced his findings, but others did not. Some Roman Catholic authorities labeled him a heretic. This is someone whose views are in conflict with the church's teachings. See, they believe that the Bible teaches a geocentric solar system, contrary to Galileo's observations. But Galileo believed that the Bible was silent on this issue.
Cardinal Caesar Baronius said, "The intention of the Holy Spirit is to teach us how to go to heaven, not how the heavens go."
Some church leaders still insisted that the heliocentric model contradicted the Bible. They cited passages to back it up. Psalm 93:1 says, "Surely the world is established so that it cannot be moved."
The question is, what does that word moved mean? Does it mean that the earth can never have any motion at all? Or does it mean something different? And there's more than one word in the Hebrew vocabulary of the Old Testament that has the idea of motion. But this particular word, interestingly, is directly related to another word that shares the same root, a noun, motah. The verb is mot, and the related noun is motah. Motah is routinely translated yoke. So it has the idea of an orderly relationship that is designed to make motion orderly, as in 2 oxen that are yoked together and are pulling a plow to plow a field. It's not that the oxen are not moving at all, but they're moving in an orderly way. They're not chaotic in their movement.
When Galileo saw these moons orbiting Jupiter, he realized that that is proof that not everything orbits the Earth. And that led him to believe in the heliocentric model of the solar system that had been proposed by Copernicus and refined by Kepler. Planets indeed orbit the Sun.
During a series of trials held by the Roman Catholic Church, Galileo was ordered to stop teaching heliocentrism. Galileo spent the rest of his days confined to his villa near Florence under house arrest. But unfortunately for his critics, the cat was out of the bag.
You know, I've had the same kind of experience as Galileo. When I look at Jupiter in a small telescope and I see those 4 little moons dancing around it, it's just a delight to see the clockwork motion that we see in the heavens imposed on it by the creator of the heavens. Jupiter's delightful because it never looks the same twice. It's got these wonderful cloud features on it, belts and zones, and sometimes storms will develop on them, and there's the great red spot that circles every once in a while, and so it just never looks the same twice, and it always looks majestic and gorgeous. When Galileo pointed his telescope up and saw these things that no human being had ever seen before, he knew he was onto something. He knew that astronomy was going to blossom into something that was truly remarkable. He was seeing the glory of God revealed in a way that no human being had ever imagined. And he speculated that the telescope would bring even more discoveries in the future, which of course it has, as we've built bigger telescopes and with better equipment and so on, and we've peered deeper into space. We just see the glory of God revealed in ways that our ancestors could only have imagined.
Progress in astronomy went from a slow crawl to an explosion of knowledge almost overnight.
Over the past 400 years, technology has improved a lot, and so today we have far better telescopes than Galileo could even have dreamed of having. And that allows us to see much farther, much deeper than we ever had before. Even amateur astronomers now have telescopes that are better than many professionals just a few years ago. I'm sitting here in an observatory with a 36-inch telescope, a fine instrument. At one time, not long ago, it would have been a world-class telescope. But we've had an incredible amount of improvement in the technology.
Think about it. With just a good pair of binoculars, we can see almost as much as Galileo saw through his telescope. And he only saw a tiny fraction of what we can see with equipment like what they have here at the Mount Wilson Observatory. And yet, with that telescope, he changed everything. The contributions of Galileo and Kepler changed how astronomers viewed our place in the universe. We were no longer the center of it. But still, no one knew why. Why do planets orbit the sun? Why do they move in ellipses? Why do the ones further from the sun orbit slower than those closer in? Christian thought suggested that there had to be a reason, an underlying force that explained all of this. But in the 1600s, no one knew what it was or how to prove it. It would be up to another creation scientist with biblical thinking to solve these riddles. Join us next time as our journey takes us still deeper into the universe. Once, the night sky was a realm of magic, home to gods and goddesses, to mythical beasts, to the unknown and the unknowable. But with the spread of Christian principles, we looked again and we saw the stars through different eyes. It was no longer a place to fear. It was a place of wonder. Hi, I'm Marcus Lloyd, and welcome back to The Universe, a journey through God's grand design. In the last episode, we talked about the earliest days of astronomy. We looked at the contributions of faithful scientists like Copernicus, Kepler, and Galileo. Their biblical convictions led them to believe in a universe that was the creation of a rational God, a universe that we can probe and come to understand. As the Christian worldview reached across Europe, it brought new ways of looking at things. No longer were the heavens the dark and frightening place of our superstitious past. Now we saw order and design everywhere, God's design. Stars moved in a set pattern that allowed ancient mariners to navigate ships similar to this. It was a universe that the human mind could explore and understand. Scientific knowledge went through a period of explosive growth. The invention of the telescope extended the range of celestial exploration far beyond what anyone had anticipated. By the mid-1600s, we knew the basic structure of the solar system. But for the first time, we understood that moons orbit planets and planets orbit the sun in elliptical paths. But we still didn't know why. Scientists of the day couldn't grasp the reason. What force could cause the planets to move as they do? It would take some creative biblical thinking to answer that question. Today, we're going to look at one of the most brilliant men in history, Sir Isaac Newton. His work broke barriers and broadened our horizons. It was a turning point in the history of mankind, and it marked the birth of modern science. Newton's discoveries would eventually allow humanity to build craft that would actually travel into space.
Roger, the clock is operating. We're underway.
This one man set us all on a whole new journey. Born in 1642, a year after Galileo's death, Isaac Newton was intensely private and reluctant to publish his remarkable discoveries. His friends loved him, and his detractors hated him. But few could doubt that he was one of the greatest minds the world has ever known. Newton focused his studies on calculus, optics, the laws of motion and gravity. He also passionately studied the Bible, particularly the prophecies of Daniel. He spent his spare time reading philosophers of the day and kept a set of notes where he jotted down questions from time to time.
Isaac Newton was simply one of the greatest physicists who ever lived. He made tremendous contributions to mathematics and physics, particularly in the development of calculus. Newton formulated his 3 laws of motion as well as his law of gravity, and these are very simple rules. You can write them down on an index card, but if you follow them through to their conclusion, you can use them to send astronauts to the moon. They are that powerful.
A body at rest tends to stay at rest, and a body in motion tends to stay in motion unless acted upon by an outside force. The acceleration of a body is equal to the force acting upon it, divided by the body's mass. For every action, there is an equal and opposite reaction.
Newton was very interested in astronomy. It was a fascination of his. And when a comet appeared in 1680, it reignited his interest in astronomy. He had already read Kepler and Galileo, but at that time, they still didn't know why Kepler's laws worked. What was the underlying mechanism? Newton set out to answer that question.
The breakthrough came, of course, when Newton saw an apple fall from a tree.
Why should the apple fall directly down and not in some other direction?
Sounds like a simple question, but the answer changed the world.
Assuredly, the reason is that the Earth draws it. There must be a drawing power in matter, and the sum of the drawing power in the matter of the Earth must be the Earth's center, not in any side of the Earth.
The mass of the Earth exerts a force on the apple, an attraction called gravity. But when the pull of gravity extends out into space, why doesn't the moon fall towards the Earth's center, like the apple? Leave it to Newton to figure that out.
He's sitting under the apple tree. The apple falls to the earth, and he wonders, why doesn't the moon fall to the earth the same way the apple does? He set about to answer that question. Now, if you were to take an apple and throw it some distance forward, it would not fall straight down. It would form an arc. It would hit the earth, but it would hit it some distance away. Imagine if you threw it really far so that it was actually out over the ocean before it finally touched the surface of the earth. Well, since the earth is round, it's actually curving away from the apple as it falls, and so the apple will hit at a lower distance than where it was first launched. Now imagine you threw an apple so hard that it fell at the same rate that the earth curved away underneath it. In that case, the apple would never get closer to the surface of the earth. It would make a complete loop and come back to its point of origin. That essentially is an orbit.
Newton realized that the moon does the same thing. It goes around the Earth for the same reason. The moon is like that apple. It's moving so fast it would go in a straight line, disappearing out in space. But Earth's gravity keeps pulling at it. Gravity makes it move in a loop around us. It falls just like the apple, but the moon is falling around the Earth.
Sometimes gravity is called the glue of the universe. It holds everything together. It keeps the moon going around the Earth, it keeps the Earth going around the sun, and it keeps the whole Milky Way galaxy revolving, tightly held together by gravity. The moon and the Earth are tied together by gravity. The gravity force keeps the moon in its orbit, and of course the moon pulls back on the Earth and causes the tides. Now, gravity is a bit of a mystery. It's invisible. We're not quite sure what it is, but it acts all the time. It even holds us on the ground as well. And between the Earth and the Moon, it adds up to a very large number, millions of tons of force.
Newton's laws of motion and gravity can be used to compute the motion of almost everything in our universe. For the first time, scientists understood why planets and moons move the way they do. Still, Isaac Newton remained modest about his many achievements.
If I have seen further, it is by standing on the shoulders of giants.
He must have seen a lot because he managed to set science on a whole new course. This was the first time that physics on Earth had been applied to outer space. Many ancient cultures believed that space was divine and obeyed different rules. But the Bible teaches that Christ is Lord of both heaven and earth. The Christian worldview says the whole universe, here and above, submits to God's power. So, everything obeys the same laws. Newton understood that God was behind all of this.
Gravity explains the motion of the planets, but it cannot explain who set the planets in motion. God governs all things and knows all that is or can be done.
When Newton published his book, his friend said, "Well, Isaac, you've done it this time. You're explaining everything. We don't need God anymore." And when Newton heard that, he spoke right up and said, "That's not what I did at all. I'm showing you how God put it together. God's revealing to me his handiwork." In other words, Newton was a godly man. He had a great respect for Scripture and his maker. In fact, Newton wrote more theology than he did science. He spent a lot of time studying the Scriptures.
Newton literally wrote the book on physics in his Principia, but he followed that a couple of decades later with his work, his great treatise on optics, and it became the standard text for 200 years. Much of his book was about how the light is actually a wave. You can break its light up with a prism into shorter and longer wavelengths or different colors from violet to red.
He also found that you can recombine those colors into white light again using lenses. And this answered a long-standing problem that astronomers were having with their telescopes. Up until that point, all telescopes used two lenses and to bring light to a focus, and that's the way they were able to magnify objects.
And one of the problems we've had from the very beginning with telescopes, ones that use lenses, is a problem called chromatic aberration. The lenses themselves would act like prisms and would split the light and make a little rainbow hue. It's kind of pretty, but on the other hand, it blurs the images terribly.
This chromatic aberration produced a purple halo around planets and stars, making good observations difficult. For years, astronomers struggled with the problem. Then, Newton fixed it. He replaced the primary lens with a mirror, a polished, rounded metal mirror. Glass bends different wavelengths of light by different amounts, but a polished surface will reflect all wavelengths equally. In theory, using a mirror should eliminate chromatic aberration. Pure silver was expensive and corroded quickly. So Newton experimented with several other substances before settling on 6 parts copper and 2 parts tin. The result was almost as bright as silver and reflected plenty of light. Now this was important because the more light that was reflected, the better the view. Newton's telescope completely eliminated the purple halo, resulting in images of perfect color. Newton had demonstrated the potential advantages of the reflecting telescope. Over time, telescopes would come to use glass mirrors with coated silver or aluminum on the surface. These are easier to grind and further improve the quality of images. But the basic design of the Newtonian telescope is still in use today. The poet Alexander Pope said, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." By the late 1700s, a lot of astronomers were using Newtonian telescopes, resulting in many new discoveries. William Herschel was a British astronomer who constructed his own version of the telescope. Along with his sister Caroline, he began a search for binary stars in 1774. These are 2 stars in orbit together. To the eye, they look like one point of light. Through his telescope, Herschel saw that they were separate stars. He discovered several hundred of these binary star systems.
He made lots of discoveries, one of which he realized that some of these cloud-like objects seen in the night sky, what we call nebula, some of these were actually clusters of stars. That was a hint that there might be other galaxies out there.
He also looked at many stars, trying to figure out if there were binary stars. These are two stars orbiting one another.
The discovery of binary stars and the way they orbit each other shows that Newton's laws work in deep space just the same as they do on Earth. This led to even more discoveries. Astronomers would eventually use Newton's laws to compute the mass of binary stars, or how much material they contain.
When we want to find the mass of something, we usually weigh it. You step on the scales in the morning, and if your weight went up, that's a force of gravity between you and the Earth. It's probably your mass that is accountable for this. Now, you could ask, well, how do we find the masses of stars? Well, if we had some scales big enough, we could have them stand on it, but that's not very practical, is it? So what we do instead is we measure, again, the gravity, but this time it's the gravity between two stars in a binary system. They attract each other by their mutual gravity, and the motions they follow, the orbits they follow, depend directly upon that gravity, and from Newton's law of gravity, we can figure out what the masses are.
While searching for double stars, Herschel made a discovery for which he is most well known. He noticed a small blue disk. At first, he thought it was a comet. The object moved slowly from night to night like a comet would, but it lacked the usual fuzzy appearance of a comet, and there was no tail. He saw that its motion was a nearly circular orbit, more like a planet. Herschel realized he had discovered a new planet beyond the orbit of Saturn. This was the first planet to be discovered since ancient times. Our ancestors, all the way back to Adam and Eve, could see 5 planets with their naked eyes: Mercury, Venus, Mars, Jupiter, and Saturn. In time, people came to understand that Earth is a planet as well. But William Herschel found one more, a planet that you can't see easily with the naked eye. Following tradition, the planet was named for a mythical god. It was called Uranus, after the Greek god of the sky, because of its light blue color. Later, Herschel discovered 2 moons of Uranus, Titania and Oberon.
By the mid-1800s, astronomers realized that the orbit of Uranus seemed to deviate slightly from what was predicted on the basis of Newton's laws of motion and gravity. Now, Newton's laws of motion and gravity had been very successful in accounting for the motions of the other planets in the solar system, so it seemed likely that those laws were correct. But what could account for the unusual motion of Uranus? 2 mathematicians independently realized that another planet orbiting beyond Uranus could cause Uranus to move that way by pulling on it with its gravity. Urbain Le Verrier and John Couch Adams independently worked out the solution to this problem and found that yes, indeed, there must be a planet orbiting beyond the planet Uranus, pulling on it, and they computed the position of the as yet undiscovered planet. Le Verrier mailed in his prediction to the Berlin Observatory, and within one evening, astronomers there were able to locate this new planet, which we now call the planet Neptune, and it was within 1 degree of the coordinates that Le Verrier had predicted.
The discovery of Neptune was a triumph of Newtonian physics. It was hailed as one of the greatest scientific discoveries of the 19th century. Using Newton's laws of motion, his law of gravity, using calculus, mathematicians were able to find a new planet. This wasn't an accidental discovery with a telescope. This was a search made with mathematics, with calculations on a sheet of paper. Because of this, Le Verrier was called the man who discovered a planet with the point of his pen. So astronomers finally understood why stars and planets move the way they do, but they hadn't yet figured out what stars are. Before the influence of the biblical worldview, people believed that stars were divine. It was considered bad luck to point at a star because, as they saw it, you were pointing at a god. That could anger the spirits. In some cultures, it was even believed that pointing at a star could cause a person to die. There were some who believed that shooting stars held the souls of the dead, or the soul of a new life coming to earth. But the Bible teaches us that stars are creations of God and aren't things you worship or fear. In Jeremiah 10:2, we're warned against this kind of superstition. Thus says the Lord, do not learn the way of the Gentiles. Do not be dismayed at the signs of heaven, for the Gentiles are dismayed at them. It would take a whole new field of science before we actually began to understand what stars were made of.
Newton's discoveries in the field of optics paved the way for an entire new branch of astronomy, which we now call spectroscopy.
One of the pioneers of this field was a German physicist named Joseph von Fraunhofer. He invented a device that split white light into a spectrum of colors with a much higher resolution than a prism. Fraunhofer found that when he passed sunlight through his spectroscope, The spectrum had small black lines in it. Apparently, some wavelengths are missing from the sun's light. It seems every light-emitting substance produces a unique spectrum, a sort of atomic fingerprint. The field of spectroscopy allows us to identify the composition of any such substance.
As you got into the part of the 19th century, people began to realize that these different spectral lines were due to different elements. Hydrogen would produce certain lines, calcium, other lines, iron, other lines. And so this allowed us to do a lot of things. First of all, it allows us to figure out what the stars are made out of. That understanding really wasn't finished until the early 20th century.
Once scientists understood this, new doors were opened to them.
Just by the type of light that is emitted and breaking it down into a spectrum, we can identify the composition of anything in the universe. It's a wonderful thing that the Lord has constructed the universe in that way, that the objects themselves, stars, give information about what they're made of.
So we know today, for instance, the sun is about 75% hydrogen, about 1/4 helium, and a few percent everything else. And that's pretty common among the other stars, but you can learn many other things. You can look at what's called a Doppler shift. If a star is moving towards you or away from you, those spectral lines are shifted to different ends of the spectrum, towards shorter or longer wavelengths. And if we measure that, we can figure out how fast things are moving toward or away from us. That's been very important in modern cosmology. If we didn't have spectroscopy, again, we wouldn't know much about the stars.
Spectroscopy showed differences between stars, too. Certain features were strong in some and weak in others, but no two stars were the same. This confirms what 1 Corinthians 15:41 was teaching us all along. There's one glory of the sun, another glory of the moon, and another glory of the stars, for one star differs from another star in glory. When ancient cultures looked at the sky, they were overwhelmed by its mysteries. They created gods and monsters to explain what they saw. For centuries they observed, but they didn't understand. But with the spread of Christianity, things began to change. Christians eagerly accepted the challenge of understanding the stars. Believing God designed the universe to have order and rules, the early Christian astronomers watched the way the earth, moon, sun, and stars move and tried to figure out those rules. That's what science is all about, trying to understand the patterns that God imposed on His universe. God gave us intellect, and He wants us to use it to explore His creation. And what we have found confirms again and again the truth as revealed in the Bible. God upholds the universe in a consistent manner that we can understand through science and mathematics. Every new revelation leads to new questions because God delights in taking us on this voyage, this quest for knowledge. The further we venture into space, the more He reveals to us. I'm Marcus Lloyd. Thanks for joining me. On our next episode, our journey will take us into the 20th century, and we'll see some really exciting discoveries. Lift up your eyes to the heavens. Who created all of this? You know, for centuries, we've gazed into the night sky and dreamed. If only we could make the leap from looking at the stars to wandering among them. The history of astronomy is a story of discovery, a quest for knowledge. It's the story of mankind trying to get a glimpse into the mind of God. Hi, I'm Marcus Lloyd, and welcome back to The Universe, a journey through God's grand design. In this series, we're looking at ways that God's creation is confirmed by science. In the last episodes, we looked at early developments in astronomy. We saw our understanding of the stars change as science grew more sophisticated. But there's one thing that never changes, and that's our basic human curiosity. We want to understand the universe and our place in it. We all want to find how we fit in the big picture. That's how God made us, and He's placed gems of truth for us to find.
There's something in the human nature, and I would say it's because we bear the image of God, that seeks to understand the things around us, that wants to search out available resources or potential use of the things around us, to look what's around the corner, to see over the horizon, to want to know what's across this big body of water.
Proverbs 25:2 says, "It is the glory of God to conceal a matter, but the glory of kings is to search out a matter." We've seen how the spread of Christianity led to an explosion of scientific discovery. Educated people no longer thought of the night sky as the realm of pagan gods. Christians see the universe as a creation of the living God, which means it's subject to the same laws of physics and chemistry that apply on Earth, like gravity. Isaac Newton showed us how the same forces that cause an apple to fall to the ground also hold the moon in orbit around the Earth and the planets around the sun. In this episode, we'll see how the science of astronomy has changed in the modern age. The last century has been a time of unprecedented technological growth, and we have gained remarkable insights into the universe. But what about God? Have our more recent discoveries confirmed or contradicted the Bible? Well, let's find out. Let's see where this journey takes us next. The story of astronomy is still being written. Each new chapter brings incredible innovations in technology. Over the last several decades, we've made the leap from observation to exploration. But even before we began our voyages into space, science was revealing astonishing secrets. Take the invention of the spectroscope. The device opened a new branch of astronomy, enabling us to discover for the first time what stars are made of. When starlight is passed through a spectroscope, it is broken apart into the full spectrum of colors, each representing a specific wavelength of light. But astronomers noticed that certain wavelengths of light were reduced or missing. These appear as narrow black bands in the color spectrum. When starlight is split into colors, it acts like an atomic fingerprint. The patterns we saw match the spectrum of known elements here on Earth. And so, for the first time, we learned that stars were largely made of hydrogen and helium gas. Gas is found on our own planet. The stars are creations of God, just as the Bible teaches in the book of Genesis. The spectroscope showed that all stars have roughly the same composition, but scientists saw that certain spectral lines were much fainter in some stars and more prominent in others. By the late 1800s, advances in photography allowed astronomers to record the spectra of stars on film. By comparing photographs, scientists recognized that stars fell into certain natural classes. The task of cataloging and organizing these data fell to a physicist named Annie Jump Cannon. She was born in Delaware in 1863. When she was a little girl, Annie's mother taught her about the constellations, igniting a lifelong interest in astronomy. After studying at Wellesley and Radcliffe colleges, Cannon got a job at the Harvard College Observatory, where she and a group of female astronomers were paid 50 cents an hour to document and classify stars. Originally, stars were classified by the prominence of their hydrogen lines. Ones that had bright hydrogen lines, for instance, were called A-type stars. Ones with weaker lines were labeled B, C, and so on. Cannon recognized that some of these classes were redundant and reordered the sequence so that stars are arranged into 7 classes according to their surface temperature. Today, astronomers still use Cannon's classification system.
The OBAFGKM is hottest star to coolest star. So the hot types are O, the cooler types are M. And in fact, without even looking at a spectrum, you can kind of roughly estimate the class of a star just by looking at its color. So not only does the spectrum tell you its temperature, but the overall color does as well. The blue stars tend to be the hottest and the red stars are coolest. The sun's kind of in between.
The stars in Orion are a good example of spectral types. Many of the stars we see, like on the belt stars, those are O and B type stars. The brighter ones are, there's one in the upper left in Orion called Betelgeuse, and it's a red supergiant, and it's an M-type star. It's on the other extreme, but most of the stars in Orion, like Rigel in the lower right, those are all O and B type stars, very blue, very hot, very bright.
Cannon classified over 225,000 stars between 1881 and 1924. They say she could do up to 3 a minute. She was in her late 70s when she retired in 1940. The American Astronomical Society still gives the Annie Jump Cannon Award to distinguished female astronomers. But there were some troubling changes going on in the scientific community. Remember when we talked about Galileo and Newton? Those guys saw no conflict between their scientific work and their faith. They embraced the Bible. The Christian worldview inspired scientists, while the secular outlook had a limiting effect. It led them to many false conclusions and scientific dead ends. But by the time the 20th century rolled around, the influence of Christian thought and science had faded. Many people put their faith in science and forgot the biblical reasons it works in the first place. God's consistent upholding power. As early as the 1700s, some people had begun to challenge the biblical timescale of creation. They proposed that geological forces shaped the earth gradually over millions of years. They began to deny the possibility of supernatural action by God.
One of the things that Darwin did was he tried to explain patterns in zoology as a result of slow, gradual changes over time. And not just time, but lots of time. Much more time than the Bible would allow. Ultimately, we're talking in terms of millions of years. And that kind of thinking eventually went over into astronomy, where they started thinking of ideas about stellar evolution, where you had stars supposedly changing over many millions or even billions of years as well.
God had promised us uniform cycles in passages like Genesis 8:22. But as time progressed, scientists, many of them, began to forget the Christian foundation that makes science possible, and they began thinking in terms of a more uniformitarian philosophy. That is the philosophy that slow, gradual processes over long periods of time can form things like Earth's geological features, as opposed to a worldwide flood, which is indicative of what the Bible teaches.
In astronomy, that philosophy sent us down some wrong paths. In the early part of the 20th century, astronomers found a remarkable pattern. The majority of stars fell on a natural curve called the main sequence.
The astronomers Hertzsprung and Russell found a pattern in the luminosity and the temperature of stars. They found that when you plotted the luminosity on one axis and the temperature on another, most stars fell along a sequence that today we call the main sequence. And even today, the plot of temperature versus luminosity is called an HR diagram in honor of Hertzsprung and Russell. But how do we explain this main sequence?
Well, very quickly by the 1920s, astronomers were developing theories about how stars aged. They thought they started off on one end and then began to cool and evolve, as it were, towards the other end. And so they began developing the idea that stars that were hot, the O and B type stars, were early and the others were late on the other end.
Many astronomers believed that this was an evolutionary sequence, that as stars aged, they cooled off, and so blue stars evolved into red stars. Well, this is completely false, and today astronomers don't believe that anymore. Today we understand that the main sequence has nothing to do with time. It's a mass sequence.
Just because you see a pattern doesn't mean that it's a evolutionary sequence. There are many ways you can interpret it, and as a creationist, I would interpret it as a pattern of God's design showing up here. And God has designed stars, particularly the sun, to last a long time because it gives stability to the sun. Doesn't mean it's old, it just means it's stable.
Still today, astronomers call stars early and late types, even though we now understand that their place on the spectrum is determined by mass, not age. This is just one more embarrassing example of secular reasoning leading to false conclusions. Secular thinking also slowed down developments in other areas of astronomy. Take the nebular hypothesis proposed by Immanuel Kant in 1755. Kant theorized that the solar system formed from nebulous material, giant clouds of hydrogen, basically. The clouds spun and flattened and finally collapsed to become stars. Most secular astronomers hold on to this idea today. By the late 1700s, Pierre-Simon Laplace and others decided the spiral structures seen in telescopes were examples of rotating nebula becoming new solar systems. That meant that the spirals were relatively small and within our own galaxy. Could that really mean that they were solar systems in the process of forming?
But by about 1880, most astronomers had decided that the Milky Way was all there was in the universe. And so these little tiny disks, these little nebulae, were indeed what Kant said they were, little formations of solar systems. And this became the standard belief.
This had a profound influence on other astronomers and what they expected to see. They expected to see rotating disks of planets forming. And so when astronomers first discovered spiral galaxies, many people thought that perhaps those were solar systems in the process of formation. In fact, an astronomer named van Manen actually thought he could see rotation in some of these spiral galaxies. He took pictures separated by time and measured them, and he thought that he could actually see rotation. But of course, he was wrong.
Within a few years, astronomers were able to see individual stars in spiral nebulas, demonstrating that they were not solar systems in the process of forming, but were indeed island universes, much like our own galaxy.
This is a great example of seeing something that's not really there because of your philosophy.
Such secular thinking led to other astronomical misinterpretations, such as the evolution of life on other planets. Percival Lowell was an astronomer who lived in the 19th and early 20th century. He became fascinated with the planet Mars, but his secular thinking led him to some fanciful ideas about the red planet.
Mars is a very tantalizing planet. It comes close to us, but not very often, about every 26 months, and only for a month or two then. Lowell tried to take advantage of that, and he watched the surface very carefully. Word had gotten out from an Italian astronomer a few years earlier that he'd seen these little lines, grooves on the surface of Mars. He called them channels, but unfortunately the Italian word for channel is canali, and that got translated into English very badly as canals. And when you hear the word canal, you're thinking, well, a man-made or artificial structure for transporting water.
Lowell became convinced that these canals proved that there was intelligent life on Mars.
We don't see bodies of water, yet we see polar ice caps, and he thought that as the polar ice caps melted in the spring and summer, they built these canals to transport water to the equatorial regions where it was warmer, they could grow crops, and support a burgeoning population on the surface of Mars. Well, it all turns out that nothing was there. We've been to Mars many times with modern space probes. The canals aren't there. What he was seeing was an optical illusion. And also the ice caps were actually made out of frozen carbon dioxide, dry ice, not water ice. So almost everything that Lowell thought he knew about Mars turned out to not be true. Yet this really, for more than a half century, kind of established the popular thinking and the thoughts of some scientists what Mars must be like.
A lot of the early science fiction television programs and movies focused on life on the moon or on Mars or on Venus and what have you. And of course, today we know that these are toxic environments and there's no way that life could exist there. But again, this evolutionary belief that life is just what happens when chemistry is right has permeated the thinking of scientists who really ought to know better if they recognize that science has a root in the Christian worldview. But again, we see that way of thinking even today as scientists continue to look to space to find extraterrestrial life.
Lowell could only have imagined that human beings would one day send a spacecraft to such a barren place like Mars. Dreams of space travel have been with us for a long time. Hindu mythology tells tales of traveling through space, and from the Middle East, we hear stories about it in 1001 Nights. In the West, Jules Verne and H.G. Wells were masters of a style that influenced science fiction for decades. In 1902, the French filmmaker Georges Méliès showed us a whimsical vision of space travel in his short film, A Trip to the Moon. we were treated to a campier version of spaceflight in low-budget TV series from the 1930s and 40s. But in the late 1950s, it all got real.
Russia has blasted a man-made moon into outer space. On every continent and every land, the story of Sputnik 1 has dominated the front pages.
The launch of Sputnik by the Soviet Union and later the launch of Yuri Gagarin to be the first man to go into orbit around Earth really energized the space race as we know it. And of course, it's on the shoulders of those folks that were involved there that we stand on. When that occurred, there had already been a vision of space exploration defined, which included putting mankind into orbit to build a space station to go to the moon and onto Mars. And still, that's where we are at. The ultimate vision of, I think, the international vision of space exploration is to get people to Mars.
And it has all been accomplished using laws of motion and gravity discovered by the creation scientist Isaac Newton. In fact, virtually every modern discovery in astronomy is based on the basic principles laid out by Newton. He expected to find consistent laws in nature because he knew that God is faithful. Astronauts have risked their lives trusting that his laws would work in space the same way as on Earth. I wonder if Newton ever dreamed that his discoveries would one day allow humans to walk on the moon. When Apollo astronauts landed on the moon, they conducted numerous experiments, including the placement of special mirrors on the lunar surface. After 45 years, these devices are still yielding important information.
They take a laser beam and shine it through a large telescope, usually at McDonald Observatory in West Texas. And that laser beam goes from the Earth to the moon, reflects off of those reflectors, comes back to the same telescope, and they send a pulse with that laser, and they measure the time difference between when they sent the pulse and when it came back. And knowing the speed of light, we can measure the distance to the moon to a fraction of an inch.
And what we find is that the moon is slowly receding from the Earth at about 1.5 inches per year. When you go back to the Apollo project half a century ago, the moon has moved several feet since then. And even more interesting, if you extrapolate this further back in time in an unlimited way, if the moon was only half as far from the Earth as it is now, then the recession would be several feet per year, because this changing distance is not linear. Well, if you do the math and extrapolate this, it turns out that the moon, in about 1.5 billion years, would be right up against the Earth. It would be right here. And you can't do that, because if the moon is anywhere in the vicinity of the Earth, our own gravity would disintegrate it and turn it into a ring. We would have a ring like Saturn has. Now, I'm not saying that the moon is 1.5 billion years old. What I'm saying is that it cannot be anywhere near that old, or we'd be in trouble. And yet we're told in the idea of evolutionary deep time that the moon is 4.5 billion years old. It cannot be. It must be much younger than that. And actually, over a time scale of, let's say, 6,000 years, then the moon has only moved a few hundred feet, which is not noticeable.
And that's perfectly consistent with the biblical timescale.
I was strolling on the moon one day in a merry, merry month of December. May.
With each year that passed, our journey was taking us deeper into space and showing us more. The late 1950s and 60s saw the first of several unmanned probes designed for space exploration, starting with the Soviet Union's Luna 3 in 1959. And the plan was to photograph the far side of the moon, something that had been hidden from our view for nearly 6,000 years. The early attempts to send back pictures failed, probably because of the low signal strength. But when Luna 3 got closer to Earth, 17 murky pictures arrived. For the first time in our history, we saw things from space that were hidden to us on Earth. We were looking at the far side of the moon.
You know, we used to think that Venus and the Earth were very similar planets. They're about the same size, about the same density, about the same composition. People thought, at least in the 1950s, they thought that the Venus might be a very warm, tropical sort of environment. One problem we have is the fact that it's shrouded with clouds, very thick clouds. The Earth has clouds too, but at least there are some clear spots where you can see out and you can also see in. can't say that about Venus. So people just thought it was maybe a tropical paradise. Very common belief up through the 1950s. By the 1960s, things began to change. We now know very different from that. One thing we know that it has a very dense atmosphere and the greenhouse effect is just unbelievable. It's very hot. It's like 900 degrees on the surface all the time, day and night.
In 1962, the Mariner 2 spacecraft flew past Venus and was able to actually explore that by being there. That, in concert with ground observations that had been made the previous year, revealed that Venus is rotating backwards. So the sun would actually rise in the west on Venus and set in the east, the opposite of the way Earth rotates, and very slowly, by the way. Venus rotates very slowly.
That's very interesting. No other planet rotates quite so slowly, making it kind of an odd planet.
Now, both of these facts contradict what would be expected in the secular model. Because if the solar system formed from a spinning nebula, a spinning cloud of gas, really everything ought to be rotating the same way and at about the same speed, actually. So Venus just defies both of those expectations. It's very slow, and it rotates just exactly backwards from what the secular model would predict. And yet it's perfectly consistent with the creative diversity that we see in the Lord's creation.
The solar system turns out to be very different from what secular scientists thought. Earth's nearest neighbors seem to confirm the diversity of the Lord's creative mind and challenge secular thinking. But what about the outer planets? Would Jupiter, Saturn, Uranus, and Neptune follow this trend? An amazing occurrence in the 1970s allowed scientists to send space probes to all 4 of the giant planets. We'll see what they found in the next leg of our journey. When we were children, we looked at the stars with wonder. As we grew older, we began to ask questions about them. How many stars are there? What are they all made of? What guides their movement across the sky? We grew up to become scientists, astronomers, astronauts, and our journey took us closer and closer to the stars. We discovered more and more about them. Hi, I'm Marcus Lloyd, and this is our final episode of The Universe, a journey through God's grand design. In this series, we've seen how biblical thinking has advanced science. The Bible tells us that God upholds the universe by His power in an orderly and consistent way. That's what makes science possible. It's no surprise that some of the most significant advances in science were made by men of faith. Consider astronomy. The whole field rests on discoveries made by devout Christians like Johannes Kepler. We've seen how the biblical thinking of Galileo and Isaac Newton moved astronomy forward. It was people of faith who showed us that the universe obeys the same God-given laws the Earth does. It's that mathematical consistency that makes space travel possible. By studying how things move on Earth, it allows us to figure out how things will move in space because God controls them both. It lets us go deeper and deeper into space, making remarkable new discoveries. Our voyage into the universe has revealed many secrets so far, but there will always be more to learn. In this episode, the journey is going to take us all the way to the edge of our solar system. By the 20th century, a secular mindset had taken hold in the scientific community, and it led to some pretty fanciful ideas. Darwinism and uniformitarianism suggested that the universe could have been formed over billions of years through gradual, natural processes not guided by the hand of a creator. Some secular scientists even thought our solar system might be inhabited by exotic creatures that had evolved over millions of years, whole complex civilizations on other planets. They suggested that all this had taken billions of years to form, as swirling nebulas slowly collapsed and condensed, becoming the sun and the planets. But the early years of space exploration revealed discoveries that challenged this view.
My name is Jeff Williams. I'm a NASA astronaut. In 1996, I was selected by NASA to join the astronaut corps and have been serving in that capacity ever since. Over the last 20 years, my career with NASA has been dedicated primarily to the International Space Station. I've flown 4 times to the space station in 2000, 2006, 2009, and most recently in 2016. On the International Space Station, we orbit the Earth every 90 minutes. So over days and weeks and months, you see the entire planet in different lighting conditions, day and night, different seasons. You watch the seasons go by. I've spent 534 days cumulative time on the International Space Station orbiting the Earth. And in that time, I never tired of viewing the grandeur of God's work and His creative work, especially in the part of the creation that we call home, planet Earth. When I speak to public settings of different types, I often remind folks that the history of human civilization can be summarized in the history of discovery and exploration. There's something in the human nature, and I would say it's because we bear the image of God, that seeks to understand the things around us.
Many of the great astronomers of the past were Christians and biblical creationists, and they expected to find order and patterns in the universe because God had imposed order on creation.
The Bible is showing us what kind of a God He is, what kind of a creator He is. And He has chosen to reveal certain topics to us at certain levels of detail, and others He has not. But if He has gone to the effort to actually include information about the heavens in Scripture, then we should take that seriously.
In the mid-20th century, our exploration of space took us to worlds our ancestors could only dream about. We were able to see and even visit new corners of the universe. Take, for example, all that we learned in 1974 when the unmanned Mariner 10 spacecraft finally reached its destination. It showed us that the planet Mercury is a lifeless, barren rock, a lot like our moon. And it found something even more surprising. Mercury has a magnetic field. That was completely contrary to secular expectations. But just what are magnetic fields, and why do they matter?
The Earth's magnetic field is produced by an electric current down in the bottom of the Earth, in the core of the Earth, which is an electric conductor. And there's about a 6 billion ampere electric current rotating around westward in the Earth's core.
Just like batteries run down over time, we know that magnetic fields naturally decay. Large planets are like large batteries. They keep their charge longer than smaller planets. But Mercury is the smallest planet in our solar system. It's only a third of the size of Earth. If it were really billions of years old, like secular astronomers claim, how could it possibly still have a magnetic field? It would be like digging up a flashlight that was still shining even though it was buried 100 years ago. Mercury's magnetic field suggests that it is only thousands of years old, not millions or billions. And what about the rest of the planets? Those even farther from the sun? If Mercury still has one, what would we find on the others? Would they also have magnetic fields, or would they be cold dead worlds. Our journey is going to take us a little farther from home now, about 484 million miles away. To get there, we'll hop a ride on Pioneer 10. Destination, Jupiter.
You know, it's very nice to observe the planets from the Earth, but we're doing it under an ocean of air. It can really blur up the images. We're doing it from a great distance, millions, tens of millions of miles, hundreds of millions of miles in some cases. And so we're limited in what we can do from the Earth. One of the nicest things that ever happened to astronomy, is one of the greatest things that happened in my lifetime, actually, has been the space program. And it's allowed us to observe many things we could never see up except by going there.
On December 3rd in 1973, Pioneer 10 reached Jupiter and recorded stunning images of this gas giant with unrivaled clarity. The second unmanned spacecraft to visit Jupiter was Pioneer 11, which followed Pioneer 10 by a year. But our voyage into the cosmos didn't stop there. NASA scientists used Jupiter's gravity to redirect the craft to Saturn, which it reached in 1979. Pioneer 11 returned the first close-up images of Saturn and its rings. The spacecraft was equipped to measure heat and the strength of planetary magnetic fields. Just as planets lose their magnetic fields over time, they also lose their heat. Evidence of heat or a strong magnetic field would indicate youth. Pioneer 11 found both on Jupiter and Saturn. Now, so far, the journey has taken us about 886 million miles from home. Would this be the end of the road? Was this the farthest we could go into the solar system? Well, by divine providence, a remarkable celestial event occurred in the 1970s that would allow mankind to visit all 4 outer planets with a single spacecraft. And it came at just the right time, at a point when our technology allowed us to take advantage of it. What happened was a grand alignment of the planets. Jupiter, Saturn, Uranus, and Neptune formed a giant arc. That's really rare. The last time it happened was the end of the 18th century. We won't see it again until the middle of the 22nd century. A NASA aerospace engineer realized that we could use this alignment to send a single spacecraft past all 4 giant planets. With the right trajectory, the spacecraft could harness the gravitational pull of one planet to slingshot it to the next. In 1977, the unmanned space probes Voyager 1 and 2 were launched, capturing amazing pictures of Jupiter and its moons. The planet's features appeared far more turbulent than they had during the Pioneer flyby missions. It seems Jupiter's weather is very dynamic and has long-term cycles. Time-lapse images of a great red spot showed it was a swirling hurricane over twice the diameter of Earth. Some of the things we learned didn't quite match what scientists had been expecting.
We've discovered things about some of the outer planets or satellites. Io is a volcanic satellite of Jupiter. If it's billions of years old, it ought to be cold. It shouldn't have volcanic eruptions, but there it is. In fact, we've seen like 24 eruptions at once. We can see in a matter of 2 or 3 years, vast changes on the surface of Io. Where does it get its energy from to do this? You need heat to do this.
As we've seen, heat diminishes over time. The process can't last billions of years. There were still more discoveries to come. After reaching Saturn, Voyager 1 was redirected to pass by Titan, Saturn's largest moon. Titan is the second biggest moon in the solar system, and the only one with a thick atmosphere. Its atmosphere is mostly nitrogen, but there's a lot of methane too, which produces the orange color. But methane is destroyed by the ultraviolet radiation of the sun. How could there be so much methane on Titan if it's really billions of years old?
It looks like Titan has quite a bit of methane, a lot more than they would have expected from the rate of loss of methane. So it's one of those mini puzzles that would be explained by a young solar system.
The more we learned, the more questions we had. After its visit to Titan, Voyager 1 left the plane of the solar system to wander interstellar space. Its destination? A star in the constellation Camelopardalis, which it will reach in 40,000 years. In August 1981, Voyager 2 passed Saturn with a trajectory that would slingshot it to Uranus. We were going farther and farther from home and farther into the solar system. And what we were finding was taking us closer and closer to what the Bible had already told us. Creation scientist Dr. Russ Humphreys developed a fascinating theory of Earth's magnetic field. It was based on the biblical claim that God created the Earth initially as pure water about 6,000 years ago. Water is an interesting molecule because it's slightly magnetic. If God created the Earth from water, with all its molecules magnetically aligned, it would produce a strong global magnetic field. After 6,000 years of decay, it would be somewhat weaker today, perhaps the very value we observe. It's a neat idea, but does it work? Well, put on your thinking caps, because this may just blow your mind.
What I've been doing with this theory about the origin of the Earth's magnetic field is simply taking Scripture at face value, that it means what it says. So the 2 Peter chapter 3, verse 5 verse, the earth was formed out of water and by means of water. And so I just took Scripture at face value and went with it. I just took a science attitude. I said, well, if my theory is not right, then we won't see these predictions that I made coming true.
Sure enough, measurements of Earth's current magnetic field agree with Dr. Humphreys' model and confirm an age of about 6,000 years. He then wondered if perhaps God also created the other planets, moons, and stars from water. If so, then he could predict their current magnetic field strength.
Why did the sun, moon, and stars all have to start with water? Well, because if they had started with any other substance, you would either get too strong a magnetic field at the beginning or too little. For example, the sun consists mostly of hydrogen now, and if you had the same mass of hydrogen at the beginning, you would have a field that was about 20 times stronger than the field that we observe on the sun. The other planets, like the terrestrial planets, have a lot of silicon and iron and oxygen and calcium and other elements like that. Those don't have strong magnetic fields from their nuclei. So if God had started with those materials to begin with, the magnetic field at the beginning would be way too small. So it appears to be only water that gives you the right answer, and it happens to be what Scripture points to.
Applying that same reasoning to other planets, Dr. Humphreys calculated that the magnetic fields on other planets would indicate an age of only about 6,000 years. When Dr. Humphreys first came out with his bold predictions in 1984, Uranus and Neptune hadn't even been visited by spacecraft. No one knew if they had magnetic fields. As Voyager 2 traveled to these planets, it would easily be able to measure their magnetic fields. Would they be virtually non-existent, as secular scientists predicted? Or would the magnetic fields of Uranus and Neptune be strong, as Dr. Humphreys predicted? When Voyager 2 reached Uranus in January 1986, what did it find? Voyager's measurement matched Dr. Humphreys' predictions exactly. And Uranus defies secular expectations in other ways, too. It rotates on its side, with its north pole facing the sun at the time of the Voyager encounter. Just like the backward spinning Venus, this contradicts the theory that planets should orbit upright and in the same direction. The gravity from Uranus was used to slingshot Voyager 2 on toward Neptune. Neptune is nearly a twin of Uranus. It also is a blue sphere, around 4 Earths in diameter. It's speckled with white clouds and has faint belts at high latitudes. It also has an enormous spot, a cyclone that's similar to the Great Red Spot on Jupiter. And Voyager 2 found that Neptune also has a strong magnetic field, just like Uranus. This just confirms again that these planets are thousands, not billions of years old. Voyager 2 also flew past Triton, Neptune's largest moon. Like Saturn's Titan, Triton defies all evolutionary reasoning. It orbits Neptune backward, contrary to secular expectations. It also shows observable evidence of internal heat, geysers of black soot that are found all over Triton's southern hemisphere. Heat like that can't last billions of years. Voyager 2 found that Neptune also has internal heat, releasing more than 2.6 times as much energy as it receives from the sun. This again confirms its biblical age of around 6,000 years. When Clyde Tombaugh discovered Pluto in 1930, astronomers accepted it as a 9th planet. Further analysis in the 1970s showed that Pluto was smaller than they previously thought. It's only about 2/3 the size of Earth's moon. By the early 21st century, we had discovered a number of icy masses orbiting at about the same distance as Pluto. Some were nearly as big as Pluto. Should these be classified as planets? If they were, we would end up with 30 or more planets in our solar system. In 2006, the International Astronomical Union decided that it would make more sense to say Pluto wasn't a planet, so they called it a dwarf planet. It took the New Horizons probe 9 years to get to Pluto, where secular scientists expected to find a cold, dead world with a surface pockmarked with craters.
It's kind of an understanding in planetary science that old objects, old surfaces, have many, many craters upon them. And you have to renew the surface somehow by geological activity, by heat generated somehow inside. Well, they found very few craters on Pluto, vast regions of Pluto that have no craters whatsoever. This was a shock. Nobody saw this coming. In billions of years, you would expect it to have many craters. There's no mechanism where you can generate heat, so why does the surface appear to be so young? Well, maybe it's because it is young. Maybe because the surface is not that old after all.
Voyager 1 and 2 are still out there, still continuing their journey and still sending back information. They're going to places no other craft from Earth has gone before, into interstellar space, the region between stars, far beyond the reach of the solar wind at the outermost edge of our solar system. We're finding out so much so fast, we have to stop sometimes and ask ourselves, what does it all mean? What are the real lessons we're learning? Why does it matter to you and me?
I think the Christian needs to pay attention to science. They need to pay attention to astronomy, find out what's going on and learn about what's going on. And you'll be surprised. You'll find out that many things we're finding actually confirm creation. It shows that we have a wonderful creator, a wonderful designer, and it's not just a world that happened haphazardly, a world that just came about through chance or random processes. Instead, we see design and purpose in everything around us. And I think Christian, above all people, ought to be challenged and ought to be excited about these developments because they're very welcome and we find that they support a biblical worldview.
If you can't trust the first 11 chapters of Genesis, why would you trust anything else in the Bible? So Christians, they may not be interested in astronomy per se or geology per se, but they ought to care about this origins debate because it's fundamental. It is foundational to what you believe as a Christian. If God did not create us, then really we have the right to do whatever we want. Who's to tell us that there's right and wrong? Who's to tell us that there are moral absolutes?
Our exploration of outer space is possible only because God upholds his creation in a consistent and mathematical way. He's designed our minds to comprehend mathematics and to expect the universe to obey mathematical laws. But apart from the Bible, how does any of this make sense? If the universe is just an accidental result of a Big Bang, why would we expect it to obey any laws, let alone mathematical ones?
The more experience I've had in life, to include my experience flying in space and everything associated with space flight, has only deepened my confidence in the Scripture, in God's Word, the Bible. I've become absolutely convinced that there's no conflict between true science and the Scripture. If you accept that there is God, and then you apply science and observe the natural world around us, it only reinforces what the Bible says. There is no conflict.
Well, my career is physics, and that gets into the laws and the equations and all those expressions. And if that's all we had, frankly, it would get a little bit dull after a while. But to see God's fingerprint, that he set up these laws in the first place and established them and keeps them constant, it gives a whole new dimension to physics, to all of nature. And I must say, in the world of physics, the experts have never been very good at explaining where these laws come from. Well, they go back to the designer who set them up back at the creation week, and it has made our universe a dependable place.
When we look at Psalm 19, it begins with, "The heavens declare the glory of God." There are a lot of motions of the heavenly bodies and the earth that are happening every day, every second, all the time. And mathematically, they are so precise that we are only now learning to appreciate the level of precision that they must have in order for things not to go crazy.
It's just a delight to see the clockwork motion that we see in the heavens imposed on it by the creator of the heavens. As we've built bigger telescopes and with better equipment and so on, and we've peered deeper into space, we just see the glory of God revealed in ways that our ancestors could only have imagined.
Great are the works of Jehovah, studied by all who delight in them. Now, the works of Jehovah point to what he has done in making the universe, a marvelously, intricately designed universe. I just marvel at it.
There are more stars up there than there are grains of sand on this beach. And each one of them is different. Many of those stars have planets orbiting them, just as the planets in our solar system orbit the sun. The technology of tomorrow will reveal that each one of these unexplored worlds is a testament to God's creative design. I can only imagine what the future might hold. The same God that spoke countless stars into existence cares about you. Now, we've all violated God's holy standard, but he paid the penalty by dying on the cross. And he offers forgiveness and salvation to all who believe and trust in him. Will you answer God's call? Will you enjoy God's gift?